Hi everyone, I am Ozan Özgül, ESR number 5 of PersonalizeAF project. This is my first video blog and I will try to briefly introduce myself, my project, and what I'm planning to do later this year. So at the moment I'm living in the Netherlands, Maastricht, a very nice city. And yeah, this year was quite, we spent this year indoors, but hopefully starting from this summer, I will just see more of this beautiful region. So I'm a part of Department of Physiology of Maastricht University, and yeah, and my project is based on development of a software tool, a clinical tool, to quantify atrial conduction characteristics of patients with atrial fibrillation. So here you can see my supervising team. I had 3 local supervisors. Professor Schotten, Dr. Bonisti, and Dr. Zeemering are all from Maastricht University, and Dr. Guillem and Dr. Kalinin are my co-supervisors, which we will be working together hopefully by the end of this year. So first I will be going to Valencia and then to Switzerland. I'll talk about it later. So my background is I'm from Turkey. Firstly, I'm coming from Ankara, the capital city of Turkey, and yeah, I spent quite some time in Ankara. So I did my bachelor's there in electrical engineering. Then I moved to Belgium, another lovely city, which is quite close to Maastricht, actually. So I'm kind of accustomed to this region. So I did a master's in biomedical engineering and mainly on biomedical signal processing. And I moved back to Turkey and did another master's in electrical engineering. So, and for the last 3 years, I was working as a data scientist in a Turkish company where I had the chance to analyze various data sets from very diverse domains. So my interests are generally electrophysiology and mostly analyzing them, extracting information from electrophysiological signals so I can generalize it as biomedical signal processing. Also, I have quite some background in machine learning as well, especially due to my period of working as a data scientist. So machine learning is quite trendy nowadays, and yeah, it's promising, and I think it's promising in AF research as well. So I'm excited to apply some ML techniques to data that I have already. So maybe it's good to talk about my data as well. So at the moment, I had different sets of data, patient data and animal data. So most of my works are done on data coming from goats, animals, because we have lots of them, and there are a variety of patterns that it's not very easy to find in patients, because it's harder to collect data from patients. And also I have data from patients as well, but as I said, they are shorter and less patterns in them. But yeah, I'll discuss them later, probably in my second video. So let me just give you a piece of information of the main axis of my research. So what we know is PVI, so which is pulmonary wave isolation, which is basically electrically isolating the vicinity of pulmonary veins, which was observed to harbor many of those focal sources with patients with AF, is limited. Its efficiency in patients with more chronic types of AF is limited, so it doesn't work very well. Actually, it works initially, but the recurrence rate is quite large. So of course, there are many other research to understand this phenomena, but one line of research goes for finding additional sources that we can ablate, that we can isolate to deal with this problem. So of course there are different ways to do that, but local AF drivers, localized AF drivers are one of these candidate sources, because if they can be isolated, then probably AF can be maintained long and might be terminated faster. So we can define them as patient-specific localized sources with fast activity. So maybe if we can develop tools to detect regions in atria which show some repetitive activity, then we know that we can locate localized drivers, because repetitiveness should be shown by them. Hopefully we have tools to do that. So I'll do lots of things with this repetitiveness property, but one of the most important things is composite maps, which is basically larger maps, so larger than usual. So the idea is simple. So if something is repetitive, if it repeats itself over time, then maybe I can record it for different regions on atria and I can merge them. This is basically like panoramic mapping. So when you do panoramic imaging, panoramic photographs. So when you do take a panoramic photo, you basically take overlapping photos and some algorithm merge them by checking the overlapping parts. This is the same thing. So I'm going to detect repetitive patterns, repetitive activities on atria, on different regions by usage of some overlapping recording sites, and then I will just merge them. Yeah, and we'll see lots. And if we do it with HD high density grids, high density electrode arrays, then we will see a large map, but which also with very nice details, which will tell us a lot. So there are many expected results from my work, and yeah, it's quite general, but of course the first thing is we would like to perform composite activation map generation in a very principled way and understand behavior of this algorithm. So this is something I already did. So I simulated a scenario where I know what my composite map should look like, because normally you can't know that, right? Because I'm trying to enlarge an image, so I'm trying to get a larger map, larger image. Yeah, but I don't know what's actual image that I'm looking for. But I simulated a way. I had a simulated way of checking this. And I just developed a composite mapping algorithm and checked if its behavior is optimal, and it looks so, which probably I'll be talking about in my next video. And now I'm going to be more interested in the content of these maps. So what's in that? So what it tells me, and is there anything changing between different patient groups? Yeah, but we will talk about this maybe later. So as I already said, this will be my route during my PhD. So I was in Turkey, then I will move to I already moved to Netherlands, and later this year I will be going to beautiful Valencia and then go to Switzerland for my second months, and then go back to Netherlands. So this will be my circle, and yeah, we'll see. And yeah, it was very nice to meet you, and hopefully in my second video I'll give you a pieces of my current results, which I think is quite interesting, and also I'll tell you about more details about this composite mapping, about its efficient usage, and in scenarios where it can be very interesting, efficient. Yeah, we'll talk about this, and I will be happy to be contacted through my LinkedIn account or my email. Please don't hesitate to do that. So see you next time.